Are you aware of the fact that the stars in the sky don't remain there forever? The old ones eventually have to go, just as the new ones are being born, but this is where it gets interesting. When some of the largest stars, stars 100 times the size of the sun, die, it results in an enigmatic explosion that you would even be able to see here from Earth. Why did the star's death cause this insane explosion? What happens when the death of a large star comes close to Earth? Scientists have just detected one of the biggest explosions in space, and the question you should be asking right now is, are we safe? Keep watching this video to find out more. Old stars have to die. Even the sun, that is the closest star to Earth, will die one day. When some stars die, the impact may be quiet, especially if the star is not so large, but when stars 100 times the size of the sun dies, their death will cause an unfathomable explosion called a supernova. To understand how this occurs, let's go to the beginning. How does the life of a star begin? Records show that there are about 200 billion trillion stars in the universe. To put this in another way, 200 sextillion. The number is so big that it's hard to imagine, and it makes one wonder how these stars begin their life. Well, this is the breakdown. It all starts as a nebula. A nebula is an enormous cloud of dust and gas, occupying the space between stars. It also acts as a nursery for new stars. Technically, it is a distinct body of interstellar clouds, which can consist of cosmic dust, hydrogen, helium, molecular clouds, and possibly ionized gases. Ordinarily, nebulas can span hundreds of light years and contain a mass of millions of suns, but with time, gravity would begin to pull the gas particles within the clouds closer, creating clumps of slightly higher density. The irregularities in the density of the gas are what cause the net gravitational force that pulls the gas molecules together. This is also what would make the nebula collapse. As the collapse continues to happen, the gas molecules become clustered together, and this causes them to lose potential energy, which makes the temperature keep increasing. The collapsing cloud eventually separates into many smaller clouds, each of which would likely become a star. Interestingly, the core of the cloud collapses faster than the outer parts, and the cloud begins to rotate faster and faster to conserve angular momentum. When the core reaches a temperature of about 2000 Kelvin, the base unit of temperature in the International System of Units, SI, the molecule of hydrogen gas breaks apart into hydrogen atoms. Eventually, the core reaches a temperature of about 10,000 degrees Kelvin, and it begins to look like a star when fusion reactions begin. If it collapses to about 30 times the size of our sun, it becomes a protostar. This process just explained to you is what has kept the sun and every star shining brightly for millions of years, but then something happens which causes a change of events. Let's go to when things begin to turn south and how exactly a supernova can occur. It all starts when some of these stars begin to run out of hydrogen fuel, causing them to swell up to many times their original size and become a red giant. When they eventually run out of fuel, the star would fizzle out, that is, go out slowly. This is the expected cause of events for an average star anyways. Now imagine, fuel running out of a large star at least 6 times the mass of the sun. You can't expect the star to go out slowly like the usual star fizzles. No, this is how they would go out. The enormous stars would first generate enough heat and pressure in the core to fuse elements heavier than helium, including carbide, neon, oxygen, silicon, and even iron. The fusing of this silicon to form iron atoms would result in an energy sink rather than producing energy for the star, to the use making the iron rapidly contract. It's going to be kinda like a fight between the inward pull of gravity and the outward push of radiation, resulting in the pressure shifting to favor gravity. The compression would cause the core to temporarily reach temperatures exceeding hundreds of billions of degrees. As this is happening, the infalling material collides with the collapsing core, making all of the built-up pressure to be instantly released, and turning the inward implosion into an outward explosion. As you should expect during an explosion, shockwaves would crack through the outer layers with so much energy that it would tear the star to shreds. All this would happen in a matter of seconds, and this is another term, the supernova. A supernova is a powerful and luminous stellar explosion. It is the largest explosion to take place in space, and it is beyond any human's imagination. No words can be sufficient enough to describe the magnitude of a supernova. If you were to add up all the energy that our sun will generate during its entire 10 billion years of lifetime, it still would be 1/100th of the amount of energy released in the first 10 seconds of a supernova. Yes, it is that crazy. Now that you have an idea of the magnitude of the supernova, let's get to the main cause of the buzz. Recently, astronomers witnessed a red supergiant star in its final days, and how it massively exploded and turned into a supernova, which by the way, is the first time this phenomenon has ever been observed. The star was first discovered in summer 2020 by a team of researchers at Northwestern University and the University of California, Berkeley, using the University of Hawaii's Pan-STARRS telescope at the peak of Haleakala volcano in Maui. A few months later, the telescope caught the star's death. Wynne Jacobson Galan, an astronomer at UC Berkeley and lead author of the study, described the event as very dramatic, violent, and like nothing we've ever seen. Jacobson Galan explained that the star was in a very distinct galaxy, roughly 120 million light-years away. After the team first saw this star, they got to watch it progressively get brighter while emitting gas before it blew and lit up space. The explosion happened in less than a minute. This supernova brings back memories of when people panicked that another red giant star would explode due to its unusual nature. This red giant is called the Betelgeuse. Usually, the Betelgeuse is one of the 10 brightest stars in the night sky and is located 550 light-years away in the constellation of Orion. For decades, researchers have known that it undergoes cycles of dimming roughly every 425 days, during which it temporarily loses about 1/4 of its peak brightness. But in February 2020, astronomers noticed that the star's brightness had dropped by an unprecedented 2/3, enough to be noticeable with the naked eye. This fueled speculation that the star was about to explode. The Betelgeuse is a red supergiant that is a more massive star and thousands of times shorter lived than the Sun. So, if it should explode, you could expect that the supernova will be bright enough to be visible during the daytime for weeks, especially because it is so close to our planet. However, the Betelgeuse is expected to end its life in a spectacular supernova explosion sometime in the next 100,000 years. Astronomers now estimate that a supernova occurs within our galaxy once or twice every century. Most supernovas are safely observed from millions of light-years away, but people have begun to wonder what would happen if a supernova exploded a little too close to home. If this was to happen, most of the supernova's energy would expand in the form of a gamma radiation. Gamma radiation is electromagnetic radiation that is emitted by an unstable nucleus of an atom during radioactive decay, but for most supernovas, gamma-ray bursts have lost so much energy, by the time they reach Earth, they don't pose any danger. However, if a star goes supernova within 10 parsecs, around 33 light-years away from Earth, the deadly wave of gamma radiation would strike the upper atmosphere with the fragile ozone layer, and it will begin to break down. The implication of this would be so severe because once there is no protective blanket above us, we will be left exposed to harmful cosmic radiation, cancer genetic mutation, and other radiation-induced illnesses, which would drastically spread across the population, and the effects could be felt for thousands of years. Global temperatures could also rise by as much as 3 to 4 degrees Celsius, causing ocean levels to rise and trigger catastrophic climate disasters. Coincidentally, geological evidence backs up this assumption and suggests that something similar may have happened around 450 million years ago, when a gamma ray burst from the nearby supernova, officially designated supernova 2013X, and this could have contributed to the late mass extinction. Fortunately, you do not need to panic about this happening again. A supernova exploding near Earth can only happen once every few 100 million years, and the probability of one happening anytime soon is extremely small. Also, supernovas are not at all bad. Without supernovas, the chemicals and compounds on Earth would simply not exist. Thanks for watching this video. If you know you learned something new from watching this video, click on that like button. Tell me your thoughts on supernovas, and I'll see you in the next one.